Hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Before we proceed, I kindly like to request our members to subscribe, engage us in the comment section, and also check our description boxes for various links of other similar videos which we are going to do under the concept of statistics. Now, in this particular case, I'm going to look at a specific example which I had promised from my previous videos. And this, of course, was the two specific topics of skewness and kurtosis, which we had discussed, of course, in a general case. Now, in this particular, case, I'm going to look at a specific example, which is going to shed light for us on how we can evaluate specific concepts of skewness and kurtosis, and basically from there, consequently interpret various curves which we're going to come across of a particular distribution of data. Now, in this particular case, suppose we are going to consider this data that I've given on the right side of the board. This is going to be consisting of a set of three specific values for the mean, the mode, and the standard deviation, which of course have been given from a specific set of data using these particular values. Now, if we are requested to find a particular distribution, the shape of the curve representing that particular distribution, therefore we're going to use one of the methods which I had mentioned in my previous discussion in trying to find the shape of the curve, or a particular case representing the concept of a skewness. And we can use three of the strategies which I had mentioned basically on the Pearsonian coefficient of skewness. And I've mentioned basically three sets of course, strategies which we're going to use: the Pearsonian coefficient of skewness, and then secondly, I mentioned about the Pauli's coefficient of skewness, which basically relied on the concept of quartiles. And then lastly, they talked about the concept of the moments, of course, of skewness, which they mentioned refer to the moment coefficient of skewness. And these were the three strategies which, of course, are given for trying to measure this aspect of skewness. So in this case, given the mean, the mode, and the standard deviation, therefore we're going to calculate this aspect of the skewness using an appropriate way. So I've said this one is going to rely on the quartiles, and we have not been given quartiles in this particular case, or the moments, and we have not been given moments. So therefore we're going to use the Pearsonian's coefficient of skewness in trying to evaluate our problem. And they said basically from the specific definition that according to the Pearsonian coefficient of skewness, we're going to find this skewness in terms of the difference between the mean minus, or the mean and the mode, and this is going to be all over standard deviation given as such. So in this case, we can represent our particular formula in terms of the difference between the mean and the mode all over the standard deviation. So having been given these particular values, then therefore we can try to evaluate this, and of course try to figure out the nature of that particular curve. So this is going to be basically given in terms of 32 minus the mode, which of course is 30.5 divided by the standard deviation given as such. So this is going to give us the value of 0.15. And as we said, we're going to look at various ranges of values of the skewness ranging between either above or below 0. And that's going to give specific information on various distributions of a particular set of data. So we had said that in case this value of the skewness is greater than 0, this is going to be implying a positively skewed kind of a distribution. And in case this coefficient, or this particular skewness is of course greater than 0, this is going to imply, or rather this skewness is smaller than 0, this is going to imply a negatively skewed kind of a distribution. And then lastly, we had said that if this measure of a skewness is equivalent to 0, this is going to depict a normal or a symmetrical distribution given in that particular case. Now, if you try to compare this one, we have evaluated our specific value for the skewness, which has given us 0.5, which is a value, of course, greater than 0 given as such. On this case, of course, we'll conclude that this basically from this particular set of data, this is going to be a positively skewed type of a distribution. Now, that's one of the ways in which we're going to evaluate specific, of course, concepts of moments. And of course, that's going to assist us in trying to evaluate various aspects of distribution. Now, we're going to consider in our next, of course, a discussion the concept of course, moments. And that's going to be one of the ways, of course, we're going to use in evaluating the concept of kurtosis. So catch us in our next video, and also check our description boxes for various links of other videos which we're going to do after this. So that is it for now, guys. Bye, God bless you. Catch us in our next video.